Okay, this is a recording for Algebra 1, doing some practice with solving equations when you have variables on each side. So, for example, if you have 20c plus 5 equals 5c plus 65, how do you solve this equation? So what you need to notice is that you have your two sides of your equation. I'm drawing a dotted line through my equals on vertically up and down, and we have a left side of our equation that says 20c plus 5, and we have a right side of our equation that says 5c plus 65. So we have to isolate c, but we can't until we only have c on one side of our equation. So we need to undo the c's on one side of the equation, and you can do it on any side. What you should do is think smarter and think to yourself, what's the easiest side to undo my variable on? And in this case, it would be undoing the 5c, because then we keep our c's positive by doing that. Watch what happens. If I say I want to undo 5c by subtracting 5c from it, I'm going to get 0c on the right-hand side. So I subtract 5c on the left-hand side to keep it balanced. Whatever you do to one side, you have to do to the other. So my 5c and my negative 5c or minus 5c, those zero out, and I'm left with 65 on the right. And then I go over to balance it on the left, 20c minus 5c, I'm left with a 15c plus 5 on the left. And when I say the c's are positive, I've got a positive 15c. If I would have chosen to subtract 20c from the left, that would have been okay, but then I just would have ended up with a negative 15c on the right, and I just have to divide by a negative. We can do that, but if you can attempt to keep your variable positive, you want to try to do that. So now we're left with 15c plus 5 equals 65. This is just a typical two-step equation where we're going to use additive inverse and multiplicative inverse. So we subtract 5 from both sides, and we have 15c equals 60. Now we're going to divide by 15 on both sides, and c equals 4. If we check our answer, we could plug 4 back into the original equation. Into each one of the c's, we plug a 4 into it. So 20 times 4 plus 5, that'd be 85. And 5 times 4, that'd be 20, plus 65, that would be 85. So 85 equals 85, and it checks. So that's doing variables on both sides of the equation. Let's do another one. Let's do 3k minus 5 equals 7k minus 21. 3k minus 5 equals 7k minus 21. So you notice that you have variables on both sides of the equal sign. We don't want that. We want to get them all on one side. So then we think smarter, not harder, and we realize if we take away 3k on the left, to zero that out, taking away 3k on the right from the 7k leaves our k's positive. So let's do it that way. So we minus 3k on the left. We do the same thing to the right, minus 3k on the right to keep it balanced. The 3k cancels on the left, and we're left with a negative 5. Pull down that minus 5, right? Equals 7k minus 3k is 4k minus 21. Now this should look familiar. Negative 5 equals 4k minus 21. We're going to add 21 to both sides. We cancel our 21s. We're left with negative 5 and 21 is a positive 16 equals 4k. We're going to divide by 4 on both sides, and k equals 4. If we check it, we plug the 4 back in for each spot of k. So 3 times 4 is 12. 12 minus 5, that's 7. 7 times 4 is 28. 28 minus 21, that's 7. 7 equals 7, and it checks, and we did it right. So I'll put one down for you to do, and I'll pause it. You can pause it, and then when you bring it back up, I'll do the solution with you. So let's try 8s plus 9 equals 7s plus 6. 8s plus 9 equals 7s plus 6. Pause the video, do the problem, start the video up again, and I'll go through the solution with you. All right, so we notice we have variables on both sides. It would make more sense to take away the 7s on the right in this problem because it's smaller than the 8s, and it'll keep our s positive. So we subtract 7s from both sides of the equation. We get 8s. 8s minus 7s is just s, or 1s if you wanted to write the 1, plus 9 equals 6. S plus 9 equals 6. We need to subtract 9 from both sides, and s equals negative 3. 6 minus 9 is negative 3. If we plug it back in and check it, negative 3 in for 8. 8 times negative 3 is negative 24, plus 9 is what, a negative 15. And 7 times negative 3 is negative 21, plus 6 is negative 15. So it checks out. All right, I'll give you another one to do. 5t minus 9 equals negative 3t plus 7. 5t minus 9 equals negative 3t plus 7. Pause the video, do the problem, start the video up again, and I'll go over the solution. All right, two sides of our equation, got variables going on both sides. It would make the most sense to add 3t to the right to cancel out the negative 3t. Notice on this one the trickery is the negative 3t. So we're going to add 3t to both sides. We end up canceling out our negative 3t with our positive 3t on the right, and we're just left with a 7. Then on the left we have 5t plus 3t is 8t minus 9. 8t minus 9 equals 7. Now we're going to just do our two-step process. Plus 9 to both sides to undo the minus 9. We have 8t equals 16. Divide by 8 on both sides, and t equals 2. If we check our answer, we plug the 2 back in for t on both sides of the equation. 5 times 2 is 10, minus 9 is 1. Negative 3 times 2 is a negative 6, plus 7 is a 1. 1 equals 1, and we did it right. Now let's go over a situation where things get a little messier. We use the distributive property. So we have 3 open paren a minus 5 close paren equals a negative 6. I said messy, but it's really not. If we just use our distributive property, then we can get going on this one. So we're going to distribute the 3 to the a and the minus 5 and rewrite it 3a minus 15 equals negative 6. Now this is again just a two-step additive inverse and multiplicative inverse problem. We don't even have variables on both sides on this. We're going to add 15 to both sides. Those will cancel on the left-hand side. 3a equals negative 6 plus 15, which is positive 9. Divide by 3 on both sides, and a equals 3. If we plug it back into our original equation, we'd have 3 minus 5. 3 minus 5 is a negative 2. 3 times negative 2 is negative 6. That's what we have. Negative 6 equals negative 6. So how about you do one of those? You'd have 6 equals 3 plus 5 open paren d minus 2 close paren. 6 equals 3 plus 5 open paren d minus 2 close paren. Pause the video, find the solution, start the video, and I'll go over the process. All right, on this one we distribute the 5 over the quantity in the parens. So the 5 times the d and the 5 times the minus 2. So we're going to rewrite 6 equals 3 plus 5d minus 10. Now the trickery on this one is notice you have a 3 and a minus 10 on the right hand side. You can combine those And you end up with 6 equals 5d minus 7, because a positive 3 and a negative 10 becomes negative 7. Now it's a two-stepper once you combine the 3 and the negative 10. 6 equals 5d minus 7. We're going to add 7 to both sides. We get 5d equals 13. We're going to divide by 5 on both sides, and d equals 13 fifths, or 2 and 3/5, right? And if you did it on the calculator or solved for decimals, it would be 2.6. All right. Let me show you another one using some division, and then you can do one on your own. And that should about do it for the evening. Well, we'll step it up with a distribution on both sides for our last problem. All right, so here's one where if we have some division going on, if you have c plus 1 all over 8 equals c over 4. What should we do here? C plus 1 all over 8 equals c over 4. So we probably should try to get rid of that denominator going on. So if we multiply by the value of the biggest denominator, that would get rid of that 8, wouldn't it? So let's multiply by 8. That's the same as 8 over 1. If we multiplied by 8 over 1 on the left, we got to multiply by 8 over 1 on the right. Now notice that the 8's cancel on the left, and you're left with just 1, so you're left with c plus 1 on the left equals. Now c over 4 times 8 over 1, you also have some canceling going on here, some simplifying. The 4 and the 8 have a 4 in common. So 4 divided by 4 is 1, 8 divided by 4 is 2. C over 1 times 2 over 1 is 2c. So you have c plus 1 equals 2c. Now, noticing that we have c's on both sides of the equation, we want to subtract c on the left to cancel out that positive c. So we're going to subtract c on the right. Those cancel out, and we get 1 equals 2c minus c is c. So the whole answer to this is just c equals 1. If we check it, put 1 in for c. 1 plus 1 is 2. 2 over 8. Okay, simplify that. That's 1/4. Put a 1 in for c on the right. We get 1/4. 1/4 equals 1/4, and it checks. So you can do the next one. We have 3m minus 2 over 5 equals 7 over 10. 3m minus 2 over 5 equals 7 over 10. Pause the video, do the problem, start it up again, and we'll go over the solution. All right, on this one, you're going to multiply both sides by a 5 to get rid of that 5 denominator there, going on with the 3m minus 2 over 5. So I'm going to multiply by 5 over 1 on both sides. 5's cancel, and you're left with 3m minus 2 on the left equals, now 7 over 10 times 5 over 1, we can do some simplifying by cross-canceling. The 5 and the 10 will cancel. 5 goes into 5 once, 5 goes into 10 twice. So now you have 7 over 2 times 1 over 1. So that's just 7 over 2 on this side. Add a 2 to both sides. Get rid of the 3m minus 2. We're going to add a 2, and we're left with 3m. Now, when we add a 2 to 7 over 2, if you wanted to, you could say 7 over 2 is 3 1/2. Right? 2 goes into 7 3 times, with 1 left over, 1/2. So 3 plus 2 is 5 1/2, right? And then we want to divide by 3 on both sides. Well, 5 1/2 divided by 3 is the same as 5 1/2 times 1 over 3, right? Divided by 3 is the same as multiplying by a third. So we probably want to we need to put our mixed number back into an improper, so we have 11 over 2 times 1 over 3. We're left with 11 over 6. 11 over 6. All right? Or 1 5/6. 6 goes into 11 once with 5 left over. So that one took a little work with fractions, which is really good practice to continue working your fractions. If you didn't quite follow that one, do it again. And make sure you're really careful with your fractions. All right, so we'll finish up with a distribution on both sides of the equation. So if we have 4 open paren 2a minus 1 close paren equals negative 10 open paren a minus 5 close paren. Again, I'll read that again. 4 open paren 2a minus 1 close paren equals negative 10 open paren a minus 5 close paren. So we've got 2 parens on each side. We want to just distribute each side and get rid of those parens. So 4 times 2a is 8a, and 4 times minus 1 is minus 4. That's going to be on the left-hand side, equals negative 10 times a, which would be negative 10a, and negative 10 times minus 5.
Contact the office at 141.
Sorry for the interruption. We are at school. All right, negative 10 times minus 5 would be positive 50. So we should have 8a minus 4 equals negative 10a plus 50. So we notice that we have variables on both sides. We could minus 8a on the left, and we'd get a negative 18 on the right. So how about we do a positive 10a on the right to keep our variables positive. So add 10a on the right to cancel out that negative 10a. So if we add 10a on the right, we have to add 10a on the left to keep it balanced. Whatever you do to one side, you got to do the same thing to the other side. All right, 8a plus 10a is 18a minus 4 equals 50. Now we can look at this. It's a two-stepper. Use our additive inverse, plus 4 on both sides. We have 18a equals 54. Divide by 18 on both sides, and a equals 3. Right? A equals 3. If we check our answer, we plug 3 back in for each instance of a in our original equation. So on the left-hand side, it's 2a, so 2 times 3 is 6. 6 minus 1 is 5. 5 times 4 is 20. So we've got 20 on the left-hand side. Let's make sure we have 20 on the right-hand side. Plug our 3 in for a. 3 minus 5 is a negative 2. Negative 2 times negative 10 is positive 20. 20 equals 20, and it checks. We did it right. So I'll give you one of these to do, and then you can do it and go through the solution and be done with this, practicing this particular concept. So we have 2 open paren w minus 3 close paren plus 5 equals 3 open paren w minus 1 close paren. 2 open paren w minus 3 close paren plus 5 equals 3 open paren w minus 1 close paren. Pause the video, solve for w, start the video back up, and we'll go through the solution. All right, on this one we need to distribute the 2 to the w and the negative 3 on the left-hand side. So we end up with 2w minus 6 plus 5 on the left-hand side. That equals, on the right-hand side, we're going to distribute the 3 to the w and the negative 1. So it ends up being 3w minus 3. So now our equation is 2w minus 6 plus 5 equals 3w minus 3. Notice on the left-hand side we have a minus 6 and a plus 5. Let's clean that up. Minus 6 plus 5 is actually negative 1. So we have 2w minus 1 equals 3w minus 3. Now we notice we have w's on both sides of the equation. It'd be simplest or smartest to cancel out the 2w. So on the left-hand side, so minus 2w on both sides to keep it balanced. 2w and the minus 2w cancel, and we're left with a negative 1 on the left-hand side equals w minus 3. Now to get the w by itself, we want to get rid of the minus 3 or negative 3. We're going to add 3 to both sides, and w is going to equal positive 2. If we plug back in the 2 to check it, we plug back in the 2 for the w in each instance of our original equation. So on the left-hand side, we'd have 2 minus 3, which is a negative 1. 2 times Negative 1 is negative 2. Negative 2 plus 5, we have a 3. We do on the right-hand side, we plug in the 2 for the W. 2 minus 1 is 1. 3 times 1 is 3. 3 equals 3, and it checks. We did it right. Okay, so that's all for doing some practice with equations where variables are on both sides of the equation and where you need to use all your inverses like additive inverse and multiplicative inverse, your distributive property. You need to use your combined like terms process sometimes to simplify the equations, and then when you finally get to it being a two-stepper equation, you're using additive inverse and multiplicative inverse to solve for the variable. So if you need extra practice on this, you might want to watch the video again and redo the problems. Or you could go look for multi-step equations with variables on both sides by just Googling it to get some extra problems. All right, we'll see you in the next video. Have a good day.